Hello, this is part 2 of the e-bike hub motor that I have built, and this is about the dimensions of the shaft. You can see here I got dimensions written out on paper, and I can talk to you about kind of the key things about between these two shafts that you probably might want to know. So you can see the factory shaft has a few extra features in it that are probably not needed, so you don't probably have to worry about making it look like this exactly. So that's a good thing. You see there's a hole that goes through here, and that's mainly for the wires to make it through to the other side. On this one, instead of going through the center of the shaft, it goes underneath this keyway, and this keyway allows the wires to get underneath. You see, this was drilled out with a 1/4 end mill. It was milled out pretty much from here all the way on the inside here. You see 8.5 millimeters from here to here. Yeah, pretty much. The main surfaces you want to be worried about when making this are like the bearings and the stator, and the spacing between them are important. You see here the diameter you want to try to get close to is like 17.01 millimeters. This one's a little bit underneath that size, and I can show you what I mean by it. I grab the caliper first. Oh, that's not quite correct. What's going on here? Okay. This is saying 17.1, but it really isn't consistently. Yep. Yeah, this shaft should be very close to 17 millimeters. And as I go through here, diameter kind of gets a bit smaller. And that helps to allow the bearing to slide onto the shaft. See here is a little bit of a wiggle room between the bearing and shaft, and that's pretty much what you want to avoid. Unfortunately, on my spindle, I sanded a little too far. I got a little bit of wiggle room on the shaft. So you definitely want to be a bit larger than the 17 millimeter. Or just try to sand it until it just barely fits. See, this spacing here is where usually the bearing would sit on the shaft. And so after the spacing, you can like make this shaft diameter a little bit smaller just after it, so that you can get the shaft on and off easy. This side, we have 15 millimeter, pretty much 15 millimeters spot on. And I can show you, it's pretty much spot on 15 millimeter. Zero. But yeah, it should be like 15 millimeter on this one. Pretty much 15 millimeter. Now, the thing I wish I'd done was made this a little bit smaller diameter after the bearing, because as you can see, when trying to get this off, I kind of messed it up with some pliers. That's going to be an eyesore for me to live with forever. And you see here, it fits pretty tight on the bearing, trying to set them into. But it will slide on though. But yeah, it's a pain. Oh yeah, the keyway. Pretty much this keyway, you can see like 3.56 millimeters in its depth that it sits in there, which is a little too deep actually. This one's actually a little deeper than that, but I say it's a little too deep. You can probably bring it up to like half of like 5 millimeters or so, and it'll probably be good. Yep. So this was cut out with a 1/4 end mill from over here all the way through. You see 1/4, and the distance between each side is like 6.47 millimeters. As you can see, you see the depth from this here to the bottom of this is like 4.8 millimeters, and from here to there, that's like 8.5 millimeters. So it allows you to get the wire underneath the bearing. Now the next thing I probably should talk to you about is the different sizes between a road bike shaft and usually some of the mountain bike shafts for the quick release ones. And you see, I went pretty much for the mountain bike size. It's a little larger, but the road bike one is a little smaller. I can probably show you what I mean by it. Come look it over here. Set them on there. That one's a little smaller in diameter, but over here you can see it's not gonna fit. Over on the ones that would be for mountain bikes, it fits perfectly fine. And that's pretty much what you have to be worried about on that. Now this hole, the way I drilled the hole in this, you can see, you look all the way down in there, it's not perfectly aligned with the other hole on the other side, halfway through. That's because I had to drill to the center of this on either side because my lathe isn't big enough. But yeah, stuff you have to live with. Oh, I gotta get the camera back on. Now this is the arm for it. You can see, should be just a little bit larger than where it would go for the diameter of the shaft. $17.28 or so. Thickness 18.8. or so. Over here, it's like 31 millimeter. And you can see we have a round instead of a square one. That's for a round drill bit piece for 1/4 size. And the reason why is because I didn't quite have a keyway cutter, and so I just used the end mill, 1/4 end mill, to cut that out, which is, you know, it's fine. It's not gonna end the world, of course. You have this set screw to help hold it in place. And I welded this piece of metal to it. And the spacer that pretty much is used to get the shaft off, pretty much have a 1/4 cut hole here. This was done with the 1/4 end mill. The inside diameter of this is to fit around the outside diameter of this, or the one of this, because this one's like on 19 millimeter on this outside. I'll show you. I got 1932, something like that. Side diameter. Yep, like so. Between here, somewhere around in there. The length, something like that. The overall length of the spacer isn't quite as important. It's not really that important, but just long enough for whatever setup you have. So here, what else can we talk about? Now the stator itself. You see, it's compare it to a fresh one. This one is a little discolored because it's went through a little too much heat, so they get pretty hot. So you definitely want to like try cutting holes into your hoverboard motor to try to keep it cool. Depending on where you're going to be using it. If you're using it in a lot of dirt, you want to probably avoid that and just run it at a lower power rating. And you probably should be fine. See here. Update for the middling spindle. It's kind of looking beautiful. Angular contact bearings inside there. Pretty much got a poly V belt here. This is like a J6 or something like that. 13.5 inch. It kind of goes on there. And then I'm gonna have one of those what we call sewing machine servo motors that's going to drive this. See here, this will eventually be mounted in the tail end of the lathe, and cut threads into this and cut the taper for the ER32 collets and the nut for the ER32 collets. But yeah, it's looking pretty so far. That's an update on that. You probably see that I have the HGR20 linear guide rails. I got the longer one here, and I got this one's like 1700 millimeters. This one's 1000. And yeah, hopefully that will make a pretty good milling machine. But yeah, I guess that's it so far. Can't think of anything else I can tell you about. What else? But yeah. That's pretty much everything. I guess I upload this video now.